Director at Purdue's newly launched Institute for a Sustainable Future. Thank you very much for attending today and to learn more about wildfire, water systems, and public health. We have 3 experts and several people who are experienced right now in going through implications of wildfires and their impact. We have 3 speakers today, and I will introduce them in order as they speak. I also want to say that our presentation today is being recorded and it will be available up at our website. You can also follow the current information that we have in this area first by following Dr. Andrew Welton on Twitter at the Welton Group, or our own Twitter feed, Purdue ISF, the Institute for a Sustainable Future. We will save questions till the end. Each speaker will be speaking approximately 20 minutes, and we will be using the Q&A function in Zoom to present the questions to the speaker. Also, please keep in mind, as I said, this will be recorded and you will be muted and your video off during the first hour of this presentation. And I will be presenting the questions then to the speakers. Our first speaker today is Joe Martinez. He is the Drinking Water Bureau Chief at the New Mexico Environment Department. He is the Bureau Chief and has a Bachelor of Environmental Science from New Mexico Highlands University and has worked in this field for over 20 years, focused on drinking water and environmental fields. Previously, he spent time working for the Texas Commission on Environmental Quality in the Dallas-Fort Worth Metroplex as a public water supply specialist and a member of their hazmat response team. He's spent much of his career in the field of drinking water regulatory compliance and oversight with the state of Texas, as well as New Mexico. So I'm going to go ahead and stop sharing, and Joe is going to start sharing his slides. Thank you very much.
Thank you so much for that great great intro. Again, my name is Joe Martinez. I'm the New Mexico Environment Department's Drinking Water Bureau Chief. And if you give me 1 second to share my screen, we will get going here. All right, if you can all let me know if you can see my screen. Okay, I'm assuming that you all can see my screen. Okay, thank you.
Thank you, Joe.
All right, before we get going, I want to thank the folks over at Purdue University for hosting this event and for giving us the opportunity to discuss the recent wildfires in New Mexico. I'm going to broadly be discussing our drinking water program's response to the recent fires that impacted several communities in New Mexico, and then also discuss a broad case study for the city of Las Vegas and the impact to their drinking water supply. So a little bit of background about our drinking water program. In New Mexico, we regulate approximately a little over 1,000 public water systems across the state. 570 of those are community systems serving a population of just over 1.9 million people. As far as where they're distributed, this is a representation of where most of our public water systems are distributed. The light blue triangles are groundwater systems in the state, and then the purplish triangles are our surface water systems in the state. As far as our community public water systems, the vast majority of our public water community public water systems serve populations of less than 1,000 population. You can see that 77% of our community water systems serve small populations, and only 6% of our community public water systems serve populations greater than 10,000. As far as the community water systems in our state, some of our smaller communities are challenged just like any other public water system across the country. They're challenged with having technical, managerial, and financial capacity to effectively run their water systems. They are challenged with finding certified operators to operate their water systems, and really, if there's anything much more complex than basic operations, sometimes they struggle with those kinds of things. Infrastructure is always an issue. There's a lot of old infrastructure in the state, and the costs to repair or replace that infrastructure are oftentimes a challenge for some of our communities. And then as far as climate change, longer, more frequent drought conditions, we've seen that over the past few years. Increased in water demand as temperatures rise, wildfires like we're talking about today, and post-wildfire flooding. As far as the wildfires that we experienced here in New Mexico this year, this has been one of the worst wildfire seasons in the history of the state. There were 31 wildfires that burned more than 1,000 acres in the state. And this year we had two of the largest wildfires in the history of New Mexico, combining to burn more than 666,000 combined acres. And the total acreage burned with all the fires in the state was over 850,000 acres. Here's a listing of some of the bigger fires that we had in the state. The one that we're going to focus on today is the Calf Canyon and Hermit's Peak fires. That burned 341,000 acres in the northeastern part of the state. You can see it represented in this large red area. The Black Fire was the second largest wildfire in the state, and it burned in the southwestern part of the state. And we'll talk a little bit more about those over the next few slides. As far as the Hermit's Peak and Calf Canyon fire, again, it was the largest fire in the history of the state. Recently, within the past 2 weeks, it was finally reported as being 100% contained. There were 16 public water systems that were impacted by the fire. 5 of those public water systems still remain on drinking water advisories. The McBride fire was not as big of a fire, but it did impact several public water systems, and 2 of those water systems still remain on drinking water advisories to this day. As far as the Cerro Pelado fire, that was a fairly large fire as well. It burned near the Los Alamos National Laboratory, and the Los Alamos National Laboratory and Los Alamos County for a couple of weeks were on set status in anticipation of being evacuated. I think the fire got within a mile or 2 of the laboratory property. And as I mentioned before, the Black Fire is the second largest fire in the state of New Mexico. It burned over 325,000 acres. Thankfully, this particular fire burned in an area that was not very populated, so we didn't have any specific impacts to public water systems with this particular fire. Wanted to show a couple of the news headlines for some of the for the Hermit's Peak and Calf Canyon fire as it was burning. This was covered pretty extensively by the media and continues to be covered. This last one is a news release of some of the precautionary precautionary drinking water advisories that we, along with our sister agency, the New Mexico Department of Health, issued during the wildfires. So as far as our drinking water programs, response to these fires, there was a lot of things that we kind of did and we worked to do throughout the fires. The initial thing that we tried to accomplish was to reach out to the communities that were potentially going to be impacted by the fire to get on the ground information about what they were seeing, what they were hearing, and just try and get information about what was going on in their communities. The other thing is, once we knew that the fire had impacted a community, we worked to get drinking water advisories out through the media so that people knew not to drink that water until there was a chance to evaluate those systems. We conducted post-fire system evaluations. We conducted post-fire sampling and post-fire recovery and technical assistance. And then we'll talk a little bit more about the impacts from post-fire floods. So as I mentioned, initially we tried to stay in contact with some of the communities that were at risk for the fire impacts. It was a little hard with some of the communities due to the fact that a lot of the people that were impacted by the fires had been evacuated as a result of the fire, so they evacuated the communities. The other thing that made it a challenge was that there was, during certain times of the fire, there was limited phone service in the area, so we weren't able to get in contact with local water system officials and operators to get information. So what our staff did is we used online mapping tools on the InstaWeb to help us track the fire and the potential impacts to some of the communities that were in the path of the fire. So once we were able to get in and start getting more information and actually do system evaluations, we saw two types of impacts to communities and to water systems. The first were direct impacts, and those were where fire directly impacted tanks, pumps, drinking water sources, watersheds, destroyed homes, impacted drinking water service lines, and those kinds of things. The second type of impact were indirect impacts, such as power loss due to downed power lines or burned power lines, low pressure or no pressure due to power outages, water line breaks, and water loss due to water hammer from firefighting efforts. So that was actually a big issue. Firefighting efforts in some cases were draining these smaller community systems. And then the other thing that we saw was increased consumption due to customers attempting to spray down their properties and homes and those kinds of things. As I mentioned, we issued precautionary drinking water advisories to 15 communities in the 2 counties that were affected. The precautionary advisories were based on both direct and indirect fire-related impacts. This is a list of the communities that were impacted. As you can see, most of the communities are less than 1,000 population. The last community listed here is the city of Las Vegas. It's the largest community that was impacted. Las Vegas was not issued a drinking water advisory for a few reasons that we'll go into a little bit later. But essentially, it's because we were able to get up-to-date information from them on a daily basis about their drinking water quality. And because of that, we were able to avoid issuing any kinds of drinking water advisories to the city. I specifically want to mention the collaborative work provided by our New Mexico Rural Water Association. They were instrumental in helping us with our fire response. New Mexico Rural Water Association staff were able to get into the burn area even before we were able to get staff into there to begin conducting on-site evaluations. As a matter of fact, today I just got notified that they're on site at a public water system doing an evaluation today as we present today. The Rural Water Association was able to provide preliminary information about fire impacts and water outages, like I said, even before we were able to get out and actually see these water systems on our own. Also want to mention our sister agency at the New Mexico Department of Health Scientific Laboratory Division. They're essentially our state lab. They were instrumental in getting post-fire sampling analysis completed and the results back to us so that we can make determinations on drinking water advisories staying in place or being able to be lifted. And finally, we'll go into this a little bit further. The City of Las Vegas utility staff were also essential in providing us with daily information about their water quality and water quantity that they had going on during and post-fire. As far as our response, when it was safe to enter the fire perimeter, we had staff that went on site. We developed an assessment checklist in order to consistently evaluate system impacts. We used our GIS Survey 123 to conduct those assessments. And essentially, we looked at water infrastructure. We looked to see how close the fire got to infrastructure. We looked to see if there was electrical power, checked the amount of supply that they had in storage and how many days they had. And the other thing is trying to explain to the local water operators and water officials about post-fire contamination concerns. So a little bit more about Survey 123. It was instrumental in our on-site water system evaluations. We had previously started using Survey 123 to do some other field assessments. So we repurposed what we had already started. to be able to do these online or these assessments using this application. So we used mobile devices, while we were on site to document what we were seeing. And we were also able to provide the same application to our New Mexico Rural Water Association staff and local operators to assist with those evaluations. We were able to take photos using the application, take notes, and then once staff was back in cell service, the information was able to be uploaded to the ArcGIS Survey 123 cloud application, and our staff that were in the office were able to start seeing that data even before our field staff were back at the office. So it was instrumental in our ability to conduct these evaluations. Here's a little map of where we conducted the evaluations. You can see that the bulk of them were in the area of the Hermit's Peak and Calf Canyon fires. And then in southern New Mexico, we did some evaluations for the McBride fire. And this is just a map showing the locations of the fires and the locations of where we conducted the evaluations. So now I want to transition into our case study for the city of Las Vegas and the fire impacts. You can see this photo was provided by city utility staff. This was as the fire was bearing down on their water treatment plant. So a little background about the city of Las Vegas. The locals call it it's the original Las Vegas. The community has a population of about 14,500 people. It has 2 school districts, 1 state university, New Mexico Highlands University, which I am, that's my alma mater, 1 community college, and the New Mexico Behavioral Health Institute, which is a state institution. And it's also the main hub for many surrounding rural communities. The city's drinking water sources are primarily surface water from the Guyanas River and the Guyanas watershed. The city is able to send that water to multiple raw water reservoirs that they have, as well as some a local lake that they have water storage at. They also have several wells that are not generally used due to multiple factors, but their primary source is the river and the watershed. They do use conventional surface water treatment, and their normal raw water turbidity is probably less than NTU. I had it listed here as about 10 NTU, but generally it's probably less than 10 NTU. Initial fire reports from the city indicated that a fire near Hermit's Peak came in about April 8th, 2022. The Hermit's Peak is in close proximity to the Guyanas watershed, which provides the city's drinking water. And there was concerns about the fire potentially jumping into the watershed and impacting the watershed. The Hermit's Peak fire eventually spotted into the watershed. By April 25th, the fire had grown to over 60,000 acres. On April 30th, the fire jumped the fire lines and quickly moved down the Guyanas Canyon towards the city of Las Vegas and their drinking water plant. And I'll show a couple of slides here to show how quickly this fire grew. So initially on April 4th, you can see that the fire is fairly small. And just for reference, the city of Las Vegas is down to the southeast of where the fire originally started. The star here indicates where the city's surface water treatment plant is located. About a week later, you can see that the fire has grown pretty significantly and is moving towards the northeast. I will say that during this time period, we had some pretty significant wind events that were contributing to how quickly this fire was growing. Another week later, you can see again, it's grown significantly. I want to point out on this slide that there is the solid black line indicates that there was a containment line that, and then just a few days later, the fire jumped that fire line and moved towards the city and towards the city's drinking water treatment plant. And this is I don't think this is the final map, but you can see how large this fire ended up being, and it impacted areas close to the city and around their surface water treatment plant. This next slide shows how close the fire got to their surface water treatment plant. You can see two of their raw water reservoirs, and the treatment plant is hard to see. It's a little bit easier on this next slide. You can see that the area between their treatment plant clarifiers and settling basins and the impacted fire area is probably in the neighborhood of 500 yards or so. So it got pretty close to their treatment plant. As I mentioned previously, during the fire, the City of Las Vegas utility staff and our Drinking Water Bureau staff communicated daily, probably more like multiple times per day, to get information about what the fire was doing and the specific impacts to the city's drinking water supply. Communications included daily water quality information, daily water quantity information as far as the number of days of storage that they had available, and updated fire progression and fire impacts. At the same time, when the fire was impacting the watershed, we started hearing about rumors circulating through the community that the city's drinking water had been contaminated by the fire. So the Drinking Water Bureau, we offered support to the community by issuing press releases to support the city's communication efforts to let people know that those rumors were not true and the city's drinking water supply was still safe. This next slide shows a copy of one of the press releases that the city put out. You can see on April 29th, they put out a press release to essentially tell people that the city's supply remained safe and they were still operating their drinking water treatment plant. This is a copy of a press release that we put out later in the day to kind of support the city's efforts to ask residents to use reliable sources of information regarding fire impacts and those types of things. As the fire progressed, the concern shifted from the fire impacts to their treatment plant to water quality being impacted within the watershed. Monsoon rains came soon thereafter, and large amounts of ash and debris began coming down from the burn scar. That impacted the city's ability to divert water for their drinking water treatment plant. Their treatment plant is not designed to treat water quality with the levels of turbidity that they were getting from their watershed. And you can see that this is it's hard to see in this photograph, but this is a large amount of ash and debris that had washed down from the watershed during one of the monsoon events. The city, when they were not able to divert water from their river, they took proactive action to begin drawing water from their other two raw water reservoirs that had not been impacted by ash and debris at this point. There is a limited supply of water in each of these reservoirs, but the city did a good job in quickly shifting to use this drinking water supply. This is a screenshot of the USGS stream gauge station from the river that supplies the town, and you can see that a year ago, the stream gauge height was fairly low, about a foot, and this year, due to the monsoon rains and the burn scar, the gauge height is significantly changed. They're getting a lot more water coming down from the watershed. A couple more photos of some monsoon rains and some debris that had washed down from the watershed. Communities began putting sandbags in place to try and keep floodwaters out of their drinking water sources. And then on July 26, 2022, some monsoon rains impacted one of the city's two raw water reservoirs that they were using. Ash and debris made its way into the raw water reservoir and significantly impacted the amount of usable water that the city had remaining. And here's a couple more photographs of that event. As you can see, the reservoir was significantly lower due to the amount of water the city was having to use, but at this point they were unable to use any of this water from this particular reservoir. So after this event, the city quickly switched to the other raw water reservoir that had not been impacted. There were minor treatment challenges resulting from the different water quality in the other reservoir, and our staff coordinated with the city to kind of work through some of these treatment challenges that they were experiencing. I want to say that the city did an awesome job, working through some of these treatment issues. At no point was the city's supply ever really in danger. They did a really great job operating through some really tough times.
Joe, just
As far
a short, notice that it's a 12:25. And
okay.
You have another minute and we can pass on to Cordelia.
Okay, I have like 2 slides left. So short-term treatment solutions, the city has installed a pre-treatment system to knock down their raw water turbidity to a point that their current treatment plant can handle. And long-term, they're going to need a lot of funding to replace and do some additional work on their current treatment system. Challenges, communication is always a challenge, but I want to get to this other slide about lessons learned. And the real lesson learned that I wanted to point out is that the drinking water utility operators should not be overlooked for their heroic efforts throughout the fire. I think during the fire, they had fire bearing down on them, and they stayed at that treatment plant and making sure that the city had a sufficient and safe supply of drinking water. So with that, I will stop sharing my screen. And
thank you very much, Joe. There are a few questions in the chat, and the ones that you think are most relevant, we will go over in half an hour, and maybe you might find you can comment on some of them while Cordelia speaks. So our next speaker is Cordelia Schimpf. She is a program analyst for the Public Health Division of the Oregon Health Authority. And as a program analyst, she coordinates the Domestic Well Safety Program, which aims to protect groundwater resources and promote well stewardship among domestic well communities across the state. She has experience in water insecurity research, domestic well wildfire recovery, and public health outreach. She earned her master's in public health from George Washington University and Millikan Institute School of Public Health, and a master's of education in teaching and learning from the University of Oregon. And so she will be talking about the lessons learned from the 2020 wildfire response and recovery in Oregon. Welcome, Cordelia.
Thank you for having me. I look forward to sharing a little bit about the prospects for putting together the project for domestic wells.
You are echoing.
Oh no, okay.
I tried now.
Are you able to hear me?
Echoed.
What I will do is I will call in. So we don't have any audio issues.
So while we wait for Cordelia, I'm Andrew Welton. I am a professor here at Purdue University in civil, environmental, and ecological engineering. And I want to thank everybody for taking the time to listen in today and for the efforts that you're all doing across the country on helping communities respond to and recover from wildfires. It was important that Joe and Cordelia share their perspectives and their experiences with them and their colleagues supporting their communities. And I hope that you all can benefit from understanding the lessons learned and the things that they're bringing to us. Did Cordelia disconnect?
Well, she is still in the meeting. I'm not sure where she is. So, Cordelia, I'm gonna go ahead and have Andrew, present his slide at the moment, just so that we keep moving, and, we'll check back in a few minutes.
Okay, great. Can you see the slides?
Yes.
Okay, great. So I'm Andrew Elton, I'm a professor here at Civil, Environmental, and Ecological Engineering at Purdue University, and we'll be hearing from Cordelia after I share some information here. We have helped communities out west, out east, overseas with wildfire contamination response and recovery. And so I designed this presentation primarily for you all who are in municipalities, public health, and some elected officials. And you can get more information on this Purdue University website. We've been posting resources that states can then go and take and derivatize their own from. We've been working with different federal agencies as well and trying to post up-to-date information for utilities as well. So kind of setting the stage with what Joe mentioned, Joe started talking about public water systems, these regulated water systems where we have sources and treatment facilities, storage tanks and buildings. And as you saw from his presentation, there's really a really significant way that wildfires can impact all of these assets. And historically, we've been focused on watershed runoff. Sometimes we have pipes that are above ground burn up if they're plastics, or treatment facilities are impacted, or they just simply can't remove the contamination from the water because they're not designed for it. But we also have these other systems where we can have hydrants and other infrastructure out in the distribution system damaged and buried due to heat or debris. Or contaminated, and we can have buildings that are contaminated here and infrastructure that's contaminated as well. And so one of the main issues with firefighting operations is we need pressure, and once a disaster happens, the infrastructure, your water utility operators basically become an asset of fire and emergency services where you're trying to support firefighting operations, where they're saving lives and protecting property. But another issue here is contamination, whether it be of the water, of the infrastructure, and of the plumbing. Separately, you're going to hear from Cordelia in a few minutes about private drinking water wells. And private drinking water wells are generally small, very small, unregulated systems where you have a well that's either shallow or deep. We have a casing and a supply pipe that provides it to a single home or a number of buildings or even multiple homes. And these are generally overseen or influenced by the health departments, not necessarily state regulatory agencies. And they have their vulnerabilities associated with fire as well. Now, for those of you listening in, you may be familiar with the concept of VOCs contaminating drinking water after wildfires. And it's been known for decades that you can contaminate your source water with VOCs and SVOCs and heavy metals. And it goes to a treatment facility and you can remove a lot of that material. But in 2017, the Tubbs fire occurred. In 2018, the Camp Fire occurred, and the sources were not affected. The treatment plant was not affected, but they were finding wicked high concentrations of VOCs in the distribution systems. And these were primarily sourced from smoke, soot, plastic degradation, and other materials that were finding their way into the depressurized, damaged distribution systems. And that water posed an immediate health risk. Since then, we've seen at least 15 water systems across the country. These are public drinking water systems, regulated ones, that have had some sort of VOC contamination after a fire. And so in 2017, it was the first one that was discovered, and it turns out probably there's more of these, but testing often isn't necessarily conducted in the right way where you can find it. And there was a perfect example of that out in Colorado in one small system where the operators flushed the contaminated water out that smelled like paint thinner. And then they sampled that water, sent it off to a laboratory, didn't find contamination. 2 weeks later, they did testing again, and they found that actually the water was still contaminated. And so one of the issues we need to be concerned about is the source of this contamination. And this contamination that shows up in the distribution system can originate from the soot, debris, materials, vegetation burning or structures burning in the air, and that material being sucked in through depressurized storage tank vent pipes, open fire hydrants, destroyed fire hydrants, and even buildings. And this is something that is a real issue that we believe is one of the ways that contamination get into the system. Another way contamination can get in is the thermal degradation of plastics. It could be pipes, it could be gaskets, it could be seals. All sorts of different plastics exist in infrastructure, and shallow plastics, ones that are in meter boxes that are not really heat protected, can be subject to this type of damage. Another issue is that if you have structures burning and you have contaminated water in a house, because there's generally no backflow prevention devices, if there's depressurization in the distribution system, that water can be sucked down into the distribution system through the service line. And there's generally now certain conditions that are likely to increase the possibility of contamination. And we provide this slide for you based on a Water Research Foundation project that 9 utilities are a part of. And this slide basically shows you that you can evaluate whether or not your system is more likely to have contamination or less likely based on the types of damage and depressurization scenarios in your system. The most likely situation is where you have widespread depressurization or localized depressurization, structures burned, we have no backflow preventer devices on the service lines, and that material can then find its way into the distribution system. Another aspect that we need to think about is distribution system impacts is pressure. And pressure, as I mentioned before, and I'll just repeat this again and again, when you lose pressure and have low pressure events, that allows for contamination to find its way into the system. This can happen in buildings or utility distribution systems. Power is a really big issue. So if you don't have power to your system, electricity, or even your generators are not working, that can sometimes prompt the loss of pressure because you can't keep water flowing into your distribution system, which is sometimes being used as a firefighting asset. Telecommunications can be impacted. You may not be able to identify what levels of water is in your storage tanks, your chemical feed operations, pressure and pump status. Another challenge utilities face is personnel. And this is many times personnel have families that they need to take to safety or take out of the way of the fire, and they just simply not available to be on site supporting the firefighter operation at the time that it happens. And then contamination is something else that you can have after fires. We've seen chemical contamination take place. I know many people consider looking for bacteria, fecal coliforms, and total coliforms as well. Now, there's generally 3 different phases to firefighting. There's generally 3 different phases to wildfire response. The first one is, again, transforming that asset into a firefighting capability where it's providing water to hydrants so that firefighters, whether they be local or coming in from elsewhere, can keep fire down and away from infrastructure. Your goal is to maintain pressure, and then your goal as a utility and the state is basically make sure that everybody is warned if there are situations where contamination may have occurred, that they're warned about how to use that water or not use it. Secondly, we're concerned about once we get back in and we start trying to understand what the damage is to the system, we want to isolate parts of the system that are damaged and restore pressure and control. And then we'll repeatedly hit it with samples. So we'll look for bacteria, we'll look for disinfectant residual over and over and over to reassert control over the infrastructure that's not damaged. And for that, you need laboratory support, you need surge support from mutual aid from utilities. You also need, in phase 3, start looking for chemical contamination. And this is where you're looking for VOCs and SVOCs. You find them, you flush that out, you retest, and you look to see if you can decontaminate the pipe in a reasonable amount of time. And if you can't, you can do what some places like Paradise did, where you remove and replace the assets. Now, one of the issues that we need to think about here is when you're issuing water use orders, whether you're the public water system or the state health department or the state drinking water primacy agency, you need to be thinking about these issues. So exposure. So we have seen drinking water contain 40,000 parts per billion of benzene in the water, and thousands of parts per billion of other VOCs in the water as well. You need to think about whether or not somebody should ingest that water, somebody should take a bath in it, or somebody should inhale it. And this should be directly related to what the adverse health effects could be under those conditions for sensitive populations like children. And then you want to issue advisories telling people explicitly what to do. And I will tell you, seeing many of the different participants on the call today, many of you are from different states. And that means that you may have different definitions of what a do not drink or do not use advisory is in your state, in your jurisdiction, compared to others. So there needs to be some critical thinking about what types of warnings you're going to issue and why. Generally, what I tell people to do is once you issue that warning, you test your way out of the disaster. You collect data, water testing data that gets you back to assuring that the water is safe and the infrastructure does not pose a health threat. Now, I put this slide up here, which is kind of a chronology of the first 24 hours of the Marshall Fire. And what we're looking at here is 3 different systems: the Louisville, Colorado water system, the Superior, Colorado water system, and the Lafayette, Colorado water system. What I just want to bring your attention to is in the first 24 hours, many of the utilities are pretty much on their own and they're working together across local jurisdictions. And so I would say, having been involved in several of these discussions early on, that whatever the state can do to help is greatly appreciated. If the state can take care of issuing boil water advisories or do not drink advisories, that frees up the public works director, utility director from doing other things. So that draw them away from the decision-making of keeping firefighting capability in the community and such. Another issue is, and I kind of reiterate what Joe Martinez says, is the operators today are going to be doing heroic things that they never planned they would do. And this is really important to understand. And I think a lot more training needs to come into this in terms of public safety, decision-making, response, and capability. And so whatever we can do to help these individuals make those decisions is really important. Now, to best protect the public from harm, I know there's been a lot of discussions about what chemicals to test for and which ones you don't have to test for. Initially in 2017, Sandy Santa Rosa found a whole bunch of different chemicals, and sometimes benzene was targeted, but other chemicals were present above health standards when benzene wasn't present. There's been a lot of discussion here, and I can say, based on the evidence that we've seen for public water systems, none of these contaminants or contaminant classes are panaceas for is the water safe overall. You actually have to apply a very deliberate approach to looking for VOCs and looking for SVOC contaminants to determine if the water poses a health risk. You can have different types of contamination in different parts of the drinking water system, and it's not necessarily a benzene only or a BTEX only situation for drinking water systems at the present time. So as of today, there's a VOC fire package that we've kind of compiled based on available data, and any contaminant you see there listed bold in red means that it exceeded some drinking water limit that was based on health. And the other contaminants there have been detected in drinking water distribution systems after fire, but they did not exceed any limits. Now, as more and more data is generated, that's really important so that we can kind of pull that all together. One of the challenges, as I brought up to you before, is we really don't have good awareness about how to conduct sampling after a fire. And so the example in Colorado, where that one small system flushed out the paint thinner water and then took a sample and paid $150 and sent to a laboratory, we really need to start doing some education about that to make sure that that doesn't happen. And here, what we need to do is sample the water, flush it, bring in clean water, and then sample it again, stagnate that water where it sits for 72 hours, and then that allows the infrastructure to leach the contaminant into the water to a level that if it's there, we can find it, and then pay for that sample again. So it's a really laborious, time-intensive process, but the faster you align the resources during the response, the better off things are. Now, I just wanted to mention, since we're talking about wells, a couple things about wells here. In private drinking water wells, as it turns out, there's no published data about what you should be looking for after a wildfire in public drinking water wells. The work that you're going to see that Cordelia is doing and her team at Oregon Health Authority is really amazing, and that's going to help us chip away at what exactly we should be looking for after private wells. Right now, there's 20 different US guidance documents about what to test for. Microorganisms are the most commonly recommended. VOCs and SVOCs are also recommended. And then actually, if you look up north at Canada, some of their agencies kind of mimic what is mentioned down in the US, where there's really no agreement on what we should be looking for. So after the Marshall Fire in 2021, we went out to Colorado and helped out Boulder County and Colorado Department of Public Health and the Environment understand water quality in these private drinking water wells that are impacted. And what we did was we looked for metals, inorganics, VOCs, and SVOCs. We did not look for microorganisms. And I can tell you what we found was that benzene and toluene were found in the debris near these wells. When we went into people's homes that weren't destroyed, they had very different in-home water treatment systems. Some could remove anything from the water, and other people just had a sediment filter. Shallow wells were contaminated by debris, but we didn't actually find any VOCs. SVOCs were found in some wells. And then really backing this out, what we think could be risk factors are power and pressure loss, if there's structure damage or well damage. And then if there's any type of thermal damage, you should be testing for VOCs and SVOCs. So kind of wrapping this up, some of the emerging data that we have coming out, and I want to provide this to you now. When contaminated water gets into buildings, many of the materials that we have are plastic. And so some of these materials are copper, stainless steel, and it's like cleaning off a countertop. But if you leave the berries, to decay on the top of your countertop, that dye can get inside it, and then it can be difficult to get out. And so here what we have is some of these materials are plastics, and they uptake this contamination, this VOC contamination, and then they leach it out slowly over time after you put the clean water in the pipe or the water softener or the supply lines and such. So this is something we're working on to try to understand what's going on with contamination, where it goes in the buildings and how to get it out. There's also two one-page inspection and water testing guidance sheets for building owners and well owners. It's at plumbingsafety.org, and many of the states in some counties have downloaded these and then adapted their own for their own purposes, which is great. There's some great resources. I'm going to hear from Cordelia at Oregon Health Authority in a second here. Some of the work that they're doing, as well as there's some great resources from EPA and FEMA as well. So with that, if there's 10 things that I would recommend you doing and understanding when it comes to wildfire attack of water distribution systems or wells, this is it. So keep power and pressure, keep heat away, isolate damage to lessen the pressure loss and the spread of contamination, issue water orders to protect the population from the exposure and consider the risk factors. Make sure you're properly chemically testing the water system. I will just diverge here in a second. Insurance companies sometimes are hiring consultants that don't understand how to actually do this testing, and they're paying for the testing, they're doing it, and then homeowners are coming up behind them and doing it right and finding contamination. So it's really important that the authorities and the agencies put out guidance that is based on evidence that gets towards the goal of understanding whether or not contamination exists. Mutual aid is really important. Rapidly seeking post-fire expertise is also important. Look, success is partly driven by having the best information available. If you're a state, a county, a utility, you want the best information available so that you can use that to make decisions. And I think what we've started to see from some of the discussions today is Joe Martinez and New Mexico are doing really heroic things supporting the community. And I think that kind of moves us towards a better protection of public health, which is what we all want. you have any questions, feel free to contact me. I'm happy to answer any questions after this. There's a there's a course that Purdue University put together about building water systems. It's a 10-hour self-paced course online, and this is helpful for those of you who are looking to understand what type of guidance they should issue after a fire. And so thank you very much. I'll leave this up here, and I am all done.
Thank you very much, Andrew. And just a reminder, the videos will be available and the website is up as well in those slides. Cordelia, are you able to join us by phone now? I think we just need to unmute her. Robbie, can you unmute her? There we go. Great. Cordelia.
Hi, can you hear me?
Yes, we can. Great. So go ahead and share.
Great, yeah. Thanks, Andrew, for your flexibility, and yeah, I apologize for the audio issues. So I'm going to go ahead and share my screen. So as Andrew mentioned, I'm going to be sharing a little bit about domestic wells and our response to the 2020 wildfires and the development of our domestic well testing project. First, I just want to introduce the Domestic Well Safety Program team. We're a pretty small team, and we try to harness our resources to provide support to domestic well communities in Oregon. I may use the term private well interchangeably with domestic wells during the presentation, and to share that the Oregon Health Authority's Public Health Division is located in Portland. And I'll start out with sharing a little bit of background about the Domestic Well Safety Program. Domestic wells, also known as private wells, are used for purposes like drinking, cooking, washing, or bathing. Nearly 23% of Oregonians rely on domestic wells as their primary source of potable water. This makes groundwater protection and well stewardship important to public health. The Domestic Well Testing Act of 1989 applies to the sale or exchange of real estate with the domestic well. And during the real estate transaction, the seller must test the well for bacteria, nitrates, arsenic, and share the results with the buyer and with OHA. And properties with spring wells, irrigation-only wells, or wells located on undeveloped land are not required to complete this testing. And data from this act can allow OHA to tailor outreach and education, as well as notify well owners about options to address poor water quality. And the program works to protect the lifelong health of people in Oregon with respect to their private drinking water. And we partner with local health department and other state agencies to assess, manage, and risks associated with private wells. The program has had intermittent funding since 1989, including 8 years of federal funding ending in 2020. So since then, the program has been partially funded to participate in target projects, including this wildfire testing. And public health modernization is helping us bring on some more permanent capacity. So the Domestic Well Testing Act that I described is currently the only law in place for domestic well water quality in Oregon. And So the mission is really to promote domestic well safety with a lack of that regulation, and to teach well owners how to take care of their wells and know what to look for and what to test for to keep their water safe. So regular testing and maintenance of private wells helps them understand the water quality and also implement some actions, treatment. So as I mentioned, we are focusing on domestic wells here, and that's wells used for drinking, showering, and cooking. And generally, they do serve no more than 3 households and less than 10 people. If it serves more than 3 houses or 10 people, then that would be considered a small community water system. And community water systems are covered by drinking water services. That's the department at OHA that regulates drinking water quality of public water systems. And domestic wells can come in many different sizes and configurations and operating conditions. They can be constructed at different depths, locations, which can affect their maintenance and water quality. And based on Census Bureau data and information from the Oregon Water Resources Department, it's estimated that there are approximately 350,000 active wells in Oregon and around 3,800 new wells created every year. Several counties have decreased reliance on private wells, most likely due to being connected to another water source, a public water source. And under this Domestic Well Testing Act, we require the testing of common contaminants found in Oregon, and so that includes testing every year for bacteria and nitrates, and also testing for arsenic once or every 3 to 5 years if levels are above maximum contaminant level. And this is showing the various state programs in Oregon providing drinking water services. So there's a Water Resources Department, and there you can find information on water rights. They have the well log database, where they house all the registered wells. That's where you can find information about the well and certification information for well construction. And I've shared a little bit about the Domestic Well Safety Program, and there's the Drinking Water Services. They enforce drinking water quality standards and provide technical assistance to water systems. And then the DEQ protects groundwater and groundwater management areas. They sample domestic well networks to monitor those areas of concern. And I'm going to now share a little background about the 2020 wildfires in Oregon. And in early September 2020, high east winds combined with existing and potential fire sources and dry conditions to create really devastating wildfires in Oregon. And these fires caused widespread evacuations, contributed to fire-related fatalities, and exposed people across Oregon to harmful levels of smoke. The wildfires also damaged and destroyed an unprecedented number of residential structures, over 4,000 estimated, and led to tremendous property loss. A federal disaster was declared for Oregon, these wildfires. In October 2020, the Oregon legislature allocated funds to OHA to pay for domestic well water testing for an estimated 2,000 households impacted by wildfires. And the budget also passed in 2021, so we could continue this project, and it's still active through June 2023. The wildfire impacted domestic well testing project is what we created with these funds. And we had an eligibility criteria. So the property was impacted by the Oregon wildfires. The well water was used for drinking, bathing, cooking, and washing dishes, and the well was not part of a regulated water system. To make sure this work was prioritized efficiently, a cross-functional task force was created, the Potable Water Resources Task Force, and provided collaborative oversight for all wildfire-related issues and actions surrounding potential impacts to drinking water. So it was led by OHA and DEQ and the Oregon Office of Emergency Management. And so we focused on supporting restoration of watersheds that provide or impact drinking water sources, and also making sure Oregonians have safe drinking water, and that's for public water systems and for domestic wells. And so the initial steps were assessing impacted public water systems to identify any recovery needs and funding gaps. Testing public water systems for the presence of fire-related pollutants, and then, of course, for the domestic wells, opening applications to provide free well testing vouchers to impacted well users. Over the course of about 6 months, a small team put together a program in short time, and really what was offered was the education and outreach to the communities, and also the free well testing. But before testing, we did recommend a few steps, which was, of course, to begin by completing a well damage assessment to identify damage level and next steps. And Andrew shared some great information about how wells can be impacted by wildfires, the integrity of wells, and also following recommendations in the well damage assessment, making sure to know what the well user is authorized to do, and what is required to be done by a licensed professional. And so the actions may include, repairing and replacing damaged well components, repressurizing and refilling the well, flushing the water lines, treating the well for contaminants, and then after this initial assessment, that it's time to test the water. And we recommended testing through and contracted with accredited laboratories in Oregon. Well users completed an application, and this application was to receive a voucher. And at the same time, through this application, we could collect more data on the well location, the post-fire condition of the well and property, as well as information about the applicants to better understand the affected communities. So we did collect some REAL-D information in an effort to increase and standardize race, ethnicity, language, and disability data. And after completing the application, eligible well users received vouchers to test well water. And the testing package included the standard package, so the common contaminants found in Oregon that we also require for the Domestic Well Testing Act, and that's the bacteria, nitrate, arsenic, lead, and then also the addition of the VOCs, VTECs. And this strategy, the VOC VTECs, came about through looking at some limited or past research, but also CDC recommendations. And after testing, our process was to follow up with the households, the well users that had exceedances. So the labs would send us the reports and we would provide some outreach to them in terms of what the contaminant is, the health risks, and next steps to treating. And to estimate the number of properties impacted and to provide outreach, we contacted local public health agencies, on-site programs, and realtors associations. And we worked with some community-based organizations to distribute information to the communities. This slide is, I'm going to share some of the results, and this is an ongoing testing project, so we will continue to receive more data through the next year. And so there are about 10 counties impacted by these wildfires, or I should say at least well users in 10 counties that applied for a voucher. And so from February 2021 through July 2022, that's what this data represents. OHA enrolled 234 domestic well users in the voucher project across these 10 counties. And so this table is focusing on the number of tested wells with lab results showing contaminants exceeding the MCL. And I want to note that a well may have multiple exceedances, and that was the case for some of these wells. So OHA ended up receiving so far 113 lab results, and about 48% of voucher recipients have redeemed their vouchers. So that could mean many things. It could mean that they are still in the recovery process if they completely lost their homes, having to rebuild that and repair the well before they can even test their water. It could also be hesitancy. That's something I will talk about in lessons learned in a few slides. But among those who redeemed vouchers, 43 well users, or 38%, received lab results with contaminants exceeding MCLs, maximum contaminant levels, and several well owners received lab results with more than one exceedance, as I mentioned before, so bringing the total number of contaminants to 1. And bacteria, coliform, was the most frequently occurring contaminant. And it often is for our real estate transaction testing data as well. So it could mean that there was some damage to the well and contaminants leaching in, or there could have been existing issues with the well. There are 29 wells with positive coliform, and 25% of that made up 25% of all lab samples. And there are 4 samples that were positive for E. coli bacteria. So again, that could indicate that system integrity was breached as a result of the wildfire, leading to the microbial contamination. And really the limitation here is that without knowledge of the system damage, it's very hard to know for sure what the cause was. And there are 16 samples that came back with arsenic levels exceeding the MCL, with most occurring in 1 county. And that does follow certain patterns of what we see in terms of arsenic hotspots in Oregon, in particular 2 regions. Some wells did have BTEX levels above the reporting limit, but none had levels that could impact health or levels exceeding the allowable limits. And there were no exceedances found for nitrate so far. So the list of counties correspond with the well address, and of course, total coliform can be present with or without the presence of E. coli. And you can see that here that there was more coliform than E. coli. And this is a map that shows some of the fire perimeters in Oregon during 2020, and I'm hoping you can see well enough to locate the areas where, so the red points or drops are the wells that had exceedances, and then the X's are the wells that had lab results with no exceedances. Doesn't mean that they don't have different contaminants, but just not the contaminants that were in the testing package. And so there are definitely some counties that were impacted more by wells that were impacted more by these wildfires, and Lane County in particular had the largest number of wells with exceedances.
Cordelia, we just have a few more minutes. We want to allow some time. For
Great.
questions. Great, thank you.
Yeah, that's perfect. I am moving on to my last slide. So wildfire recovery time was a big barrier for domestic well communities to repair their wells and get their water tested. And this also contributed to some, what we are guessing, testing hesitancy due to the very high cost of repairing infrastructure. And we do offer resources. The Oregon Water Resources Department has a well abandonment repair and replacement fund for communities that meet the eligibility, and so they're able to do well repair. And yeah, the interesting result was that there was no deep exceedances, which was surprising because there were a large number of wells that had melted or burned components. And so that causes us to kind of rethink, why could that be? Is there an issue with, could there have been an issue with the sampling process, or, we need more knowledge on the condition of the well. And then lastly, it's important to integrate recovery and resilience activities for all hazards preparedness and protections. So as we face more frequent and extreme wildfires and events, we have to consider integrating these activities for all hazards to develop frameworks and the flexibility to work through any kind of situation. Thank you very much for listening. There's a few people I wanted to acknowledge for their contributions to the domestic well safety program and this project, including developing the project, developing the fire perimeters, and helping with the data collection. If you have any questions or would like to reach out to me about our process for developing the program, please feel free. The contact information is on this slide. Thank you.
Great, thank you so much, Cordelia. So there are a few questions in the chat that I will turn to now in the time we have left. And the first question is from Curtis Cood for Dr. Welton. And he asks if we have enough evidence to recommend that folks replace synthetic tubing in the water supply. Andrew.
So we know that service lines that are high density polyethylene or cross-linked polyethylene are vulnerable to permeation. And so if there is contamination in the system, then it's possible that's where the contamination may go. Inside buildings where we're talking about very small diameter tubing, we're just generating data now that shows that a pretty large amount of it goes and gets sucked up into the tubing. We don't know exactly how long it takes to remove it. It would be a function of the magnitude of contamination, how long it sat stagnant in it. So I don't have an answer to what to do now with it, but that would be something that I would be pushing my insurance company towards understanding before they were to tell me that everything is fine in my house. So we need more work in that area as well.
Okay, great. So I think that's Dr. Wells identifying some of these gaps that are important for us to be keeping track of. And I think it's maybe a good advice as we have our first responders there, you know, to be collecting some of this information. We have another question for Cordelia, and I think this ties in a little bit with what Joe has touched on as well. In terms of the private well testing, I think Cordelia, you mentioned that there were vouchers, but maybe you could clarify who exactly was paying for the voucher system that you set up. And I think it was 3 years in length, if I understood your presentation correctly. And Robbie, I think you need to unmute Cordelia.
Is that better? Okay. Yes, the funding was emergency state funding, so from the legislature, and we had funding through 2021, I believe, and then we were able to amend our contracts and continue offering the testing project through 2023. And so that is, it's funding the various program activities around this wildfire response, as well as funding the vouchers for well testing.
Thank you. Okay, the next one, and I think this must be for you as well, Cordelia. Were you able to compare the well test results prior to the fire? So was there any type of baseline for any of these wells that got tested after?
Yeah, and that's a really great question, and it comes down to kind of building that research capacity. And because we only have the real estate transaction data to be able to apply to that, to answer that question, it is difficult to really get an accurate baseline. There are a number of transactions that happen without the testing, and so a big part of what we do in the program is to promote that testing and to educate communities to continue testing their water on a regular basis. So short answer, no. And if we did have the additional funding, retesting also, post-fire and post-recovery, is also a really interesting, question to explore.
Great, thank you very much. Let's see if we have Megan Saver was wondering about surface water resources at the watershed level. And I think Cordelia, this might also be for you.
That is a little outside of my expertise. I would definitely refer to the team in drinking water services, DEQ, Department of Environmental Quality. They were really the agencies that were we're looking at the watershed systems that source water, drinking water.
Okay, great. I'm gonna move on to one for Dr. Welton. Renee Sharp asks, as resources flow from the federal government to state and local governments for replacing lead service lines, considering the results of the research that you have done, would you recommend the use of plastic piping versus other materials less susceptible to fire damage from a health protection perspective? Good question.
So I think it's a little more complicated than that, primarily because when disasters happen, the federal taxpayers pay to remove and replace the infrastructure. So while we're paying to provide communities funding here in Indiana to California and elsewhere, when disasters happen, the federal taxpayer money is also moving to those states too, to repair situations that maybe could have been preventable or avoidable. So I think communities in states need to think about that. How many times they want to repair and replace infrastructure, and even in the infrastructures existing, what is their plan to keep vegetation away from it so that it doesn't become compromised due to wildfire caused thermal degradation or damage. So I don't have a for and against plastics approach. I would say that the materials have tremendous engineering properties. They allow us to do things that metals simply can't enable us to do. But communities, when we're talking about resiliency, need to understand, the resiliency is the ability for us to bounce back from misfortune or change. And if we know that there are certain parts in our systems that are more vulnerable to damage and attack, then we need to plan to replace them more rapidly, instead of necessarily assuming that it's not there or not, testing fully to make sure that all the contamination is gone.
Thank you. And the last question we have here, and I'm not sure if this is for Joe or for Andrew, but it's asking about, well, I guess this really is for Joe. The city of Las Vegas has the city of Las Vegas experienced long-term impacts due to the compromised properties at the water treatment plant?
So that's a hard question to answer, but I do think that they've experienced some long-term impacts. Their watershed was completely destroyed. So it's, the quality of water coming down from that watershed is significantly different than what they had prior to the fire. So they're going to have to deal with that either through improving their water treatment plant, including improving their water treatment processes. In addition, I showed a few photos of one of their raw water reservoirs that was impacted by flood and debris runoff. They're going to have to dredge that to clean it up and get some of that material out of there. So I think it's going to be a long road to recovery for them. But they, like I mentioned in the presentation, they've done an excellent job up to this point. And we will be there alongside with them to work with them along the way.
Great, thank you very much. Let's see, there's a few more. For Dr. Welton, would burying the infrastructure deeper help with reducing damage caused by fire?
Yes, under certain conditions. So the ground is an insulator to some degree, but where it's not insulated is meter boxes, or where the pipe comes out of the ground and goes into the mobile home or goes into the house. And so we can better protect our assets by moving them further away from where the heat is. And that would be one way to have a system become more resilient to wildfire.
Great, thank you. I think that is the one remaining question for Cordelia about the private wells and whether or not they were in agricultural regions, because they noticed that there was no, well, I guess you weren't testing for nitrates necessarily.
Yeah, we did test for nitrates, and that's a good question. There are some counties that do have, Oregon in general has a lot of agricultural land, and but yeah, there wasn't any we weren't concerned that, there would be some crossover with potential runoff from agriculture and, merging within the wildfire perimeters. So that's not what we were seeing in the data, the testing data either. So I would say most wells were not in those agricultural regions that often will contribute to nitrate contamination.
Great. Thank you very much for your answer. So right now, there are no other questions in the chat. I wonder if any of our speakers have questions. Oh, wait, there was one more, sorry. Can the speakers provide, this is from Richard Remedio. Can the speakers provide any insights on any reported or concerned health effects experienced by residents due to wildfire-related drinking water contamination?
So speaking for New Mexico, we don't have any of that information at this point. We don't have reports of illnesses or anything of that nature with respect to drinking water contamination. Thankfully, most of the smaller communities where the fire impacted, the actual infrastructure wasn't impacted. They were able to get some fire lines in there, and the water system itself wasn't impacted. So at this point, we just don't have enough information about health impacts.
Hi, this is Cordelia from OHA. Yeah, so we also don't have the data to really make that determination, and also a lot of our focus was really on prevention for these communities. And really one of the big factors that impacted health was the wildfire smoke in Oregon, across Oregon.
After the campfire, we conducted a survey of populations impacted, and about 60% of the population self-reported anxiety, stress, or depression, and linked it to water, saying that the concept of water, the water contamination, the stress brought on by thinking about water like they had to, was related to some adverse health effects to them in the sense of anxiety, stress, or depression. I've not seen a CDC CASPER study or some type of large-scale study looking at headaches, nausea, symptomatic cases of chemical exposure. The levels in some places have well exceeded limits that could cause that to happen, but I have not yet seen it in the literature.
Great, thank you, Dr. Welton. There is one note in the chat, maybe in relation to this too. Of note is that the Little Bear Fire near Ruidoso, New Mexico, filled Benito Lake with debris and ash in 2012. It is used as a source of drinking water by several communities. It is just now coming back online after being dredged. So definitely important to address some of those remediation issues before going back online. All right, it is 1:29 and it is the official ending of our session. If there are additional questions, feel free to stay online. The speakers will be on for a few more minutes. If there are any additional questions that you can put in the Q&A chat.
I'd like to just jump in real quick and ask, since we have representatives from New Mexico and Oregon, two of the leading states, helping communities respond to this. Are there one or two, major questions that you're hoping would be answered in the next, probably day, but in the next year or two, that you kind of talk about a lot, but there's no hard answer for it?
So that's a tough question. I know that there's a lot of, I think for us, responding to this fire, we learned a lot that we didn't know previously during the course of the response. So I think as we kind of learn more about potential contamination resulting from fires, and we appreciate some of the information that you provided to us, as we learn more about that, I think it'll help us develop better responses to maybe future wildfires in our state.
Yeah, and I think it'll be really interesting when our project concludes to look at the whole story and picture of the wells that were most impacted, and really think through, the information that we gathered initially, and how we might make those changes in the future to, inform any future response to these types of events.
Great. Any final words, Dr. Weldon, that you would like to add or close upon?
Two things. First of all, I want to say it's been an honor to be on the Zoom with Joe and Cordelia, and I know they represent a whole host of people that have been helping them and working at all levels of government in the public, be informed by the public. So it's really really amazing to be here. So thank you, and thank you, Lynn, for emceeing this event, and Robert too.
I'm sure this will be one of many to come, and the Institute for a Sustainable Future thinks you will be working more on disaster resilience and response in the upcoming months. So stay tuned, and we will make sure that the link and to the video and the slides will be made available to everyone who registered. Thank you very much.